Okay, in life, everything's relative, and that also applies to atomic mass. In this revision episode for chemistry A level, we are going through relative masses. Some key definitions are coming up. Make sure you're up to speed on the fundamental particles that come up in A level chemistry. It's covered in a previous episode if you need a little refresher. We're going to build on that knowledge today. So, relative atomic mass is the average mass of an element compared to 1/12 of the mass of a single carbon-12 atom. Okay, well, what does that mean, Jono? Basically, it means that 1 AMU is defined as 1/12 of the mass of a single carbon-12 atom. So AR is the average mass of an element in the units of AMU. So, what is the average mass? Almost every element has multiple stable isotopes. This means that some atoms of an element will weigh more than others. The average mass is the average mass of the elements weighted according to their abundance. So let's take the example of chlorine. Chlorine 35 is 75% abundant and chlorine 37 is 25% abundant. So the relative atomic mass is equal to 0.75 times 35 plus 0.25 times 37. This is why if you look up chlorine in the periodic table, its relative atomic mass is given as 35.5. So let's review those specifics of relative atomic mass again. There are three key things I want you to take away. First of all, that it takes into account the natural abundance of isotopes. So like in that example of chlorine we just talked about, the relative atomic mass is based on all of the isotopes of an element. It's an all-inclusive definition. It's measured relative to 1/12 of the mass of a carbon-12 atom, okay? 1/12 of a carbon-12 atom. And the units are AMU. Using kgs would be dumb because it would be so tiny. It would be like 1.0 times 10 to the minus 27 or something ridiculous. So let's recap. Relative atomic mass is an average because almost every element has multiple stable isotopes, which are of different masses. Okay, let's build on this a little bit more. We're going to be going into relative molecular mass, which you might see written as MR. And its definition is the average mass of a molecule compared to 1/12 of the mass of a single carbon-12 atom. So you can see that A-level chemistry does have quite a lot of definitions, but they do build on each other and they are quite similar, so that should help make your revision a bit easier. Let's get into relative molecular mass. If we recall relative atomic mass, it takes into account the differences in mass and abundance of isotopes. This means that we can simply add the AR values for all the atoms in a molecule to calculate the MR, making life so much easier. Let's go through an example. What is the relative molecular mass of benzene? So benzene is an aromatic hydrocarbon that has the formula C6H6. To find the relative atomic mass, we would look at a periodic table and would see that for carbon it's 12 and for hydrogen it's 1. So if we use the formula C6H6, the calculation we need to do to calculate the MR of benzene is 6 times 12, the 12 is from carbon, and we add that to 6 times 1, the 1 is the AR of hydrogen, and that gives us 78. So putting that all together, the MR of benzene is 78. Right, I want to test you, I want some consolidation to be happening up in here. What is an AMU? So it's a unit of mass and it's equal to 1/12 the mass of a carbon-12 atom. So I hope that was a useful revision episode. Make sure you maybe listen to it again, maybe read some of your notes, maybe go on Seneca and click through the module to consolidate it. It's going to be built on a lot in A-level chemistry. It's really important for mole calculations, so make sure you feel confident with it. Good luck with your revision and thank you for joining.